Welcome all of you in this second video on the topic radioactivity. In the previous video, we discussed about the atomic structure of an atom. In this video, we will be discussing about the phenomenon of radioactivity. So let's start with the substances which disintegrate by the spontaneous emission of radiations are called the radioactive substances. The isotopes of nearly all the elements of atomic number higher than 82 are radioactive because the number of neutrons is much more than the number of protons for these elements. It was Henry Becquerel who discovered the phenomenon of radioactivity in 1896. He was working in a dark room and he left a uranium salt on a photographic plate wrapped in a black paper. And after some days, he was surprised to find that the photographic plate had been affected. He continued experimentation and he found that other salts of uranium also affected the photographic plate. So he concluded that some kind of radiations can pass through the cover of the photographic plate and affect it. He named these radiations as Becquerel rays. On further investigations, these radiations were found to be of three types: positively charged, named as alpha particles, negatively charged as beta particles, and neutral or uncharged were named as gamma radiations. The substances which emit these radiations were called as radioactive substances. Radioactivity is a nuclear phenomenon. It is the process of spontaneous emission of alpha or beta and gamma radiations from the nucleus of atoms during their decay. Radioactivity is a random phenomenon. That is, there is no law by which the disintegration of an individual nucleus can be predicted. Any physical change or chemical change, maybe heating, freezing, action of strong electric or magnetic fields, or oxidation and reduction, does not change the nature of radiation emitted by the substance and its rate of decay. So this clearly shows that radioactivity is not the phenomenon related to orbital electrons, but it is due to the instability of the nucleus that leads to the radioactive decay. In 1903, Rutherford experimentally studied the nature of radiations emitted by the radioactive substances. He found out that on subjecting the radiations given out by radioactive substance to electric or magnetic field give deflections, and the positively charged alpha particles deflects towards a negative plate, a negatively charged particle, that is beta particle, deflect towards a positive plate, and gamma radiations passes without deviation, that is, they were neutral in nature. Gamma radiations are electromagnetic waves similar to light waves and are therefore not affected by electric or magnetic field. The beta particles are deviated more than the alpha particles. An alpha particle consists of 2 protons and 2 neutrons, and it is same as that of doubly ionized helium atom. That is, a helium nucleus containing 2 protons and 2 neutrons. Inside the nucleus, the change of neutron into a proton causes the emission of a beta particle. The beta particles do not reside inside the nucleus of an atom. in the form of electrons. Beta particles emitted from a radioactive substance have energy distributed in a range from a 0 to a certain maximum value. Beta particles produce X-rays when they are stopped by the metals of high atomic number and high melting point. Gamma radiations are the electromagnetic waves like X-rays and light, but they differ from X-rays and light in wavelength. The wavelength of gamma radiations is of the order of 10 raised to power minus 4 nanometer, whereas the wavelength of X-rays is in the range of 10 raised to power minus 2 nanometer, and that of light is in the range of 400 nanometer to 800 nanometer. Now let's compare the properties of alpha, beta and gamma rays. So first of all, we will be discussing about what are the following particles and rays. Alpha particles consists of 2 protons and 2 neutrons. Beta particles are basically electrons present in the nucleus. Gamma rays are electromagnetic waves consisting of photons. Alpha particles are positively charged particle having 2 charge on each alpha particle. Beta rays are negatively charged particles with charge of 1 electron on each beta particle. Gamma rays are neutral. The ionizing power of alpha rays is 100 times greater than beta rays and 10,000 times greater than gamma rays. The ionizing power of beta rays is comparatively less than that of alpha rays, and the ionizing power of gamma rays is minimum. It has the least ionization power. The penetrating power of alpha rays is the lowest one. They are even stopped by a thick paper. The penetrating power of beta rays is greater than that of alpha rays. They can even penetrate through a thin metal foil, whereas the gamma rays has a very high penetrating power, even greater than that of beta rays. They can penetrate through thick metal blocks. Since alpha and beta particles are charged particles, hence they deflect in electric and magnetic field, whereas gamma rays, being uncharged or neutral, are not deflected by both the fields. The speed of alpha rays changes from 1 by 10 to 1 by 20 times the speed of light, whereas the speed of beta particles, they can go up to 9 by 10 times the speed of light, whereas the gamma rays, they travel with speed of light. The radioactive substances are not stable. Their nucleus undergoes spontaneous decay by the self-emission of either alpha, beta or gamma radiation to form a more stable nucleus. The emission of alpha, beta or gamma radiation is a nuclear change. An important point to be noted: whenever there is radioactive decay, it is either going to be alpha particle or beta particle, or it's going to be gamma radiations that are going to be emitted. It means the three can't be emitted together, not even in a group of two. So a single emission is going to be there. It may be alpha, maybe beta, or maybe gamma. Alpha emission. If an unstable nucleus contains much more neutrons than the number of protons, it may emit a particle containing 2 protons and 2 neutrons tightly bound together, known as alpha particle. A stream of alpha particles is called alpha rays. If the nucleus X of a radioactive element of a mass number A and atomic number Z emits an alpha particle, due to emission of an alpha particle, atomic number Z decreases by 2 units and mass number A decreases by 4 units. Beta emission. When an unstable nucleus contains neutrons more than the protons, a neutron may change into a proton by emitting an electron. The electron given out from the nucleus at high speed is called a beta particle. A stream of beta particles is called beta rays. In emitting a beta particle, the number of nucleons in the nucleus remains same, but the number of neutrons is decreased by 1 and the number of protons is increased by 1. It changes into a new nucleus of element with properties similar to those of an element one place higher in the periodic table. The daughter product is thus an isobar of the parent atom. Gamma emission. Gamma emission occurs when the daughter or the parent nucleus is in a state of excitation. This extra energy is released in the form of electromagnetic radiation known as gamma radiation or gamma ray photon. The gamma ray takes no mass and no electric charge from the nucleus. That is, no neutrons or protons are lost. Hence, the nucleus does not decay into a different nucleus. That is, there is no change in the mass number A and atomic number Z of the nucleus in gamma emission. The star indicates the excited state of the nucleus. Thus, in gamma emission, the excited nucleus comes to its ground state. Uses of radioisotopes. The isotopes of some elements with atomic number less than 82 are also found to be radioactive, and they are called as radioisotopes. The very first use is in medical field. Gamma radiations from cobalt-60 are used to treat cancer by killing the cells in the malignant tumor of the patient. The salts of weak radioactive isotopes such as radiosodium chloride, radioiron, radioiodine are used for the diagnosis of brain tumors and blood clots. Gamma rays emitted by radioisotopes are used to sterilize bandages, dressings, syringes, and other equipments. The next is the scientific use. Alpha particles emitted from isotopes are used in estimating the size of the nucleus and in understanding the nature of nuclear forces. The radioactive traces are also used in agricultural science. Age of excavated material of archaeological importance, rocks, and hence of buried plants is estimated by the study of rate of decay of carbon-14. Industrial use. Radioisotopes such as uranium-235 are used as fuel for the atomic energy reactors. They are also used in making certain luminescent signs. The beta radiations emitted from radioisotopes are used to control the thickness of paper, plastic, and metal sheets. Sources of harmful radiations. The main sources of harmful radiations can be categorized in three ways. Let us discuss it one by one. The very first category is radioactive fallout from the nuclear power plants. The nuclear power plants are now a major source of electricity in the world. If somehow there is an accident in the reactor of a power plant, a large amount of radioactive material and radiations will escape out into the atmosphere. We have already seen a drastic damage that has caused by these radiations before. 3 such accidents have already occurred in USA in 1979, in Ukraine in 1986, and in Japan in 2011. These accidents caused damage to the reactor buildings and injuries to the persons working in the plants as well as to the persons in their vicinity. The second category is nuclear waste. The fuel rods used in the nuclear power reactors are rejected when their activity decreases. They can contaminate water and soil and affect the human and living organisms. The third category is cosmic radiations and X-rays. The cosmic radiations enter the Earth's atmosphere from the Sun and from the outer space. They contain a large number of high energy particles, out of which a large number of charged particles are deviated by the Earth's magnetic field. But still, a substantial amount of uncharged radiations such as gamma rays and X-rays reach the Earth's atmosphere. Some of these radiations are harmful for human beings. Now let's talk about the harmful effects of radiation. The biological effects of nuclear radiations are of 3 types. Short-term recoverable effects like diarrhea, sore throat, loss of hair, nausea, etc. Long-term irrecoverable effects like leukemia and cancer. And the third type is genetic effects. The first and second effects are limited to the individuals who are actually exposed to the radiations, while the third effect appears in the later generations of the person exposed to the radiation. The genes in the living cell get mutated. Now, next, let's talk about safety precautions while using nuclear energy. We can categorize the precautions. So, the very first is safety measures while establishing a nuclear power plant. The following precautions should be taken into consideration. The very first is to ensure that the people working in it are not exposed to nuclear radiations, and in case of any accident, there is a minimum spread of radiations. The second care can be taken that the nuclear reactor of the power plant must be shielded with lead and steel walls. And the third care that can be taken is the nuclear reactor must be housed in an airtight building of strong concrete structure, which can withstand the earthquakes, fires, and explosions. And the last but not the least, backup of cooling system for the reactor core should be taken into consideration, so that in case of failure, the other cooling system could take its place and the core is saved from overheating and melting. The second category is safety measures while handling radioactive materials. And the very first priority is the special lead-lined aprons and lead gloves. They should handle the radioactive materials with long lead tongs. And care should be taken that no one is exposed beyond the safety limits. The radioactive substance must be kept in a thick lead container with a very narrow opening so as to stop radiations coming out from other directions. And the last safety measures should be there in its disposal. So, the radioactive material after its use is known as nuclear waste, and the nuclear waste obtained must be kept in thick casks, and then they must be buried in the specially constructed deep underground stores. These stores must be made quite far from the populated areas. The casks then can also be buried in useless mines, and these mines must be sealed after storing the casks. The last topic of the chapter is background radiations. The background radiations are the radioactive radiations to which we all are exposed, even in the absence of an actual radioactive source. So basically, there are two sources of background radiations. The internal source, such as potassium 40, carbon 14, and radium present inside our body. And the external source is cosmic rays, that is naturally occurring radioactive elements such as radon 222 and solar radiations. It is not possible for us to keep ourselves away from the background radiations, but the total background radiations from both the internal and external sources should not exceed the maximum permissible dose for human safety. So, we need not to worry about it. So kids, with this, we finish with our chapter Radioactivity, and I hope that this video must have cleared many concepts and doubts of yours. So, with the hope that you are going to take maximum benefits of the videos given to you, and expecting that you are making maximum use of your time, it's time to say goodbye now, but you should be geared up for the next video. So we will be starting with the next chapter in our next video. Till then, goodbye. God bless you all.